Okay, today we're going to learn how to combine traditional software engineering with LLM output. And to do that, we're going to do this toy app. So it's the Infinite Cookbook. You can generate infinite mini recipe ideas. You can generate those recipes from the ideas. You can make modifications to them, as many as you want. And you can even protect yourself against malicious users. So before we get going to the details, a side note on how I'm thinking about AI in engineering. So you've seen a lot of this stuff up here, where you've got just some horrible chatbot or a magic button where it doesn't do what you want, but someone decided they needed AI in their app. This is not what we want to make. And at the same time, you've got this down here, which we typically think of as AI engineering. And it is really valuable. And I do plan on pursuing some of that this year. But I think the most important part in terms of what we as software engineers can focus on is this space in the middle, where these are some things where if we apply it correctly, it can provide a lot of value to our customers and provide some interesting challenges to us. And we're perfectly positioned to start doing these things. It's just adding another component to our toolkit, just like, using a database. All right, let's start looking at our first feature. This first feature is to generate these 12 suggestions. And so let's go ahead and go to our Groq Cloud Playground. And we're just using Groq today because it's super fast. You can use whatever you want. And let's ask it to give us 12 recipe ideas. And so you'll notice the first thing is that we cannot turn this into a React app because it's just, there it is. You can't click on these. So what we need to do is turn on JSON mode. And so now we say, okay, generate 12 recipe ideas. And we submit it, and we have to tell it that it requires JSON. Okay, so generate a JSON array of 12 recipe ideas. And it's gonna generate us an array, and it gave us recipes, name, description. Is that the format we want? Maybe it is, maybe it's not. And to be sure, we can give it what we want. So now we say generate a JSON array of 12 recipe ideas in this format. So just recipes and just a string. And let's see if that gives us what we want. Great. So this is a list that we can loop through, just like we're doing here, and turn each of them into a React component. However, if you were looking closely, you may have noticed a problem, which is that this took over a second. And that's because we're using a larger model. And so what we could do to make that faster is we can go to a smaller model. And so let's go ahead and do this one. And let's put in this same prompt again. And you can see that it took less than a quarter of the time, 262 milliseconds, instead of over 1 second. And it's also going to be a lot cheaper. However, if you are watching closely again, you'll notice that it did not actually follow the format. And I tried it again, and it still didn't follow the format. Let's go ahead and paste in what I've been using in the app. And now it follows the format. So the lower power the model, the more precise you're going to have to be with your prompts. However, they are a lot faster and a lot cheaper. So let's go ahead and take a look at how this is implemented in our system. So the user's on the main page, and then we send a GET request to our Python endpoint. And so we're using Nix.js for the front end, and we're using Python for the back end. However, you could just use Nix.js API endpoints. That would be fine because we're not actually using anything that requires Python. And even if you only know JavaScript, you should be able to understand the gist of what we're doing here. So here we have our dish ideas endpoint, and then we have our prompt, which we demonstrated in the playground. And there's a little extra there that I'll explain in a second. And then we send it to JSON completion, which in the simple version here, it just calls our completion helper function, which I'll show in a second, and then takes the content and turns it into JSON and sets return JSON to true. And here we're calling Groq, and you can use OpenAI, Claude, another inference provider, your own local llama if you really want to, and you have a gigantic computer. And it's the basic, it's just we're saying the type is JSON object, and then we're getting the message content. And so this is just so we don't have to keep writing this out every time we want to ask for a completion. So it'll return the JSON, which is then loaded, and then it'll return that JSON to our React app, and we'll just loop through that array. And you can treat it just like any other array. And that's the cool thing, is that, with JSON output, you have structures you're used to working with, and you can keep working with them, except now they can be generated on the fly using user input. Oh, and I promised that I would get back to this third line. And so this is because we don't want it to repeat ideas. And so what we'll do is when we generate the first set of ideas, next time we ask for more ideas, we'll send back that array and add this third line so it doesn't repeat itself. And it'll just keep adding more. So if you hit more ideas, oops, didn't mean to do that. More ideas, it'll just keep adding 24 this time, then 36 the next time. This input is super short, although if it was longer, you may have to start worrying about your token input, depending on how often people are doing these processes. Next, we're going to show how to actually create these recipes. So we'll click on one of them, and it'll generate the recipe. Notice it does it pretty quickly, and we get this. And we're going to look into these modifications later. For now, we're going to look at how we generate the recipe text, the recipe title, and how we prevent people from creating random React apps in our recipe creator. All right, so here is the architecture of what we do. So the user asks to generate the recipe, and so we send a post request to the generate endpoint. And here, so first, the easy one, we generate a new recipe using the recipe request. And we send that to the LLM, and we get back some text. And this text actually will come in Markdown, which is why it can show like this. And then from here, we check whether it's actually a recipe. So this is how we figure out whether someone is trying to make it do something that's outside of the scope of our app. And so what we ask is return JSON. And when I asked is recipe, just is recipe, when I asked to create a React app, it was like, ooh, what a fun, playful prompt. And it gave me a React app in a recipe format. It was weird. So I added is food. And this is part of the importance of testing your prompts. And probably if I had done a different model, either for the check or for generating the recipe, then maybe it would have acted differently. So this is something where you can't just change out your models. You have, because they each act slightly differently. So, if you ask a person to do something and you ask another person to do the exact same thing using the exact same words, you're probably going to get different results because those two people are different. Even if they're equally smart and have equal amounts of skill in whatever you're trying to do, then just they're different personalities. And the LLMs do have different personalities. So anyways, if this returns false, then we raise an exception. And then we show that exception on the front end. And then after checking whether it's a recipe, then we create the name. And notice we had to do a little bit of prompt engineering so we didn't get super long names. And also when we added modifications, it always said, oh, it's the updated version. We're like, no, don't do that. And this is how prompts get long, because you see behavior and you're just like, wait, never mind. And also we do it in JSON, so we can just grab the name and it doesn't say, oh, certainly, let me do that, which we don't want all of our recipes named certainly, I can give you a name. And finally, we put it in the Postgres database. And I'm hiding a lot of that and send it back. But because we're doing 2 JSON checks, remember, LLMs are not always doing the right thing. And so especially the smaller models can return the wrong thing, including JSON. JSON, that's not actually JSON. And so what we do here in JSON completion, we actually have a more complex version. Instead of just trusting that it's JSON, we allow for up to 3 tries. Our prompts and our models are good enough that this should be fine all the time, and it should always get it within 3 tries. But, maybe it'll fail sometimes. And it is worth checking out to see the failure rate on the prompt and the model. Because, so this prompt over here, I've noticed, I don't think I've ever seen it fail. It'll probably fail eventually. And as you saw when on the playground with a different prompt, with still just this short, it did fail. But this is such a short prompt, we're never feeding it anything else before that. Whereas here, we're feeding it a recipe. And so the recipe could be a lot of tokens. And so the more tokens you have, the greater the odds of it doing something wrong. Or I should say, the more unstructured tokens you have, the greater the chance of it doing something wrong. So if you, put in a bunch of examples showing it how to do a certain type of thing, of course that's going to make it better, not worse. But you throw in a random recipe, and now the rest of the prompt can sometimes get lost, especially with the smaller models. You have a larger, more expensive model, then that is less of a problem. So there's always this trade-off, and you have to evaluate it. Maybe next time we'll actually run some evals and show how that works. Anyways, that is how we generate the recipe, check it, and create the name. We're using a lot of LLM calls and checks on the JSON. So the rest of the features in the app, there are these suggestions, and this is, there's not a whole lot new. The most interesting thing, I think, is part of the prompt where it was giving me a lot of stuff, like changing the instructions of the recipe. And so I had to specify that it needed to be about changing the ingredients instead of just like, oh, explain more about how to cook. There's also another feature, and this is where it starts getting really cool, is you can put in your preferences. So let's say you are allergic to peanuts and you avoid gluten, and also you are low carb. And now you want a cake. And you can ask it for a cake, and it will generate one that is peanut-free, low carb, and does not include gluten. And so you'll just have your stuff automatically taken care of. This is the prompt if you're curious. And turns out there is quite a bit to prompt engineering, because I found out that if I put in a custom preference, such as I like tacos, then what it would do is it wouldn't, generate more tacos. What it would do is it would try to make every single recipe about tacos as much as it could. And that is not what you want. So whenever you have a custom prompt that you let your users fill in, especially if it's one that's pretty permanent, such as preferences, you got to be careful with how you include it in the prompts that you send to the LLM. So anyways, there's more I could talk about. I didn't even talk about how you can scrape a recipe and then customize it, and it automatically applies your preferences. And this is just sort of options that open up when you start building LLMs into your regular apps. But I'm still working on this, playing around. Tell me what you would like to see, what interesting ideas you have. and I'll keep you updated as I build this and other apps.